Hello everyone, welcome to my Relational Algebra Query Processor. I'm going to try to briefly explain the structure of the program. I have two classes. One is table and the other one is command parser. So table contains all my logic, and command parser is basically to parse strings from the command line, and basically has handle functions, and it delegates the operation to the table class. Okay, so I will start with explaining how I've structured my table class. The way I chose to represent tables is I have two attributes. One attribute is name of the table, and then a list that consists of dictionaries. So basically every row is represented by a dictionary, and the key is the column name and the value. So yeah, this way we can access immediately the value by the column name. Next, I will just go through all the operations that my table class supports. So we have a selection. Basically, I have lambda functions to match the operator and basically execute that lambda function based on what I've input, like equal, more than, not equal, less than or equal, or more than or equal. These are the only select operations I'm supporting. Hopefully that's enough. I forgot to mention that all my functions return a table, so my program does support chaining, and that's really helpful, and I will demonstrate later. Okay, so then next we have projection. Returns only selected columns. Again, nothing too fancy, just loops. Cartesian product. That's not technically official relational algebra operation, but it was in the lectures, and I thought I was going to use it for my join, and I did use it for my join, but then I found a better way of doing things. But anyways, so Cartesian product, then we have join and natural join. We have left join, we have right join. Right join, I basically reused left join, and I just flipped the tables. It does also flip the tables when I print them out, but technically it's still the same value, so it counts. Then we have full join. Then we have some set operations, intersection, union, and difference. And I do have a string representation of my tables. Basically, I'm formatting them well, so it's like all the widths and everything is matching. And yeah, that's pretty much for my table class. Okay, so command parser, we have a main function called execute, which runs in the main loop. Basically, we try to find unary match, like for unary operations, or Cartesian match, or set match, or binary match, and then we go to those handle functions. And my execute function is actually it actually works with recursion. So it will look for things. For example, in this case, I will try to show one chaining, for example. Okay, so for example, this one. So it will look first in the first brackets. It will execute that command right here, return this table, and then after that execute the next command. So chaining is possible. So I do have recursion parsing. It was difficult to implement. And basically, the base case is to return a table only, right? If it reaches the table, that's the base case. So it returns the table and then starts executing commands. So we have also, I can also support create. I can create a table. I will show how, and in my main function I show how to do that. Unary operation, select and project. Basically, uh, uh, we also have two separate functions for them, and I'll show you down. It's further down. We have the set operations, the binary operation, join, left join, which is represented by dash join, then right join dash, dash join dash is full, and so on. And this is the handle select and handle project. We can also print a table by saying right here the top left corner print and then brackets and the table name. We also have a function called print tables, prints all the tables. And this is my main function. I'm creating 3 tables for easier access, so we don't have to create tables every time, and you can experiment much easier this way. When I run my program, well, I can just actually run it. Well, I'll show you the main. So I check if like we can press exit to exit, we can create, we can print all, we can print one, or execute a command wherever you select. For example, if you do join right, and then the command basically is the text you input, and it gets delegated by the execute function. So I will run the program to demonstrate. I should probably, 1 second, let's delete that. Let's do it one more time. Okay, so there you go. Here, welcome to Relational Algebra command line tool. Example, unary commands. I show a couple of examples of how to use unary commands. Example of set commands, it's the U, and, minus symbol. Example of binary commands, it's the way I have a structure is table, then the binary command, then what are we joining on? Basically, what are the arguments? So in the tables that I have hard coded, we have names. So basically, it's a natural join, but you can also have different ones. You can have S name or yeah. So and then we have Cartesian product. To create, I give an example of how to create. So you write the keyword create, then the table name, followed by a curly bracket. Then you must press enter. Then after you write the column name, another column name, no comma, and then press enter again. Then value, press enter again, no comma, and then after I finish with closing curly bracket. Okay, and then I will just quickly show you my. So for example, let's go with print student. Actually, no, print all. So this will print all the tables. Cool. So we have 3 tables in our stored in our program. Okay, now let's do the projection. Sorry. There you go. Name and age. Boom. Name and age. Okay, let's select students. Just the student named John. Boom. Okay, there you go. Row of the student named John. Let's select the course. The match is Math 101. Boom. Okay, so yeah, there you go. John and Bill taking Math 101. Okay, let's do union. Okay, union of student 1 and student 2, which are my two tables up here. I'll just highlight them. So the union will give you all students that are unique, basically. Boom. You combine all the students, they're unique. So okay, I'll do difference as well. I'm not gonna do all the commands. I'm gonna try to keep it short. So let's do student 1 minus student 2, which should return student 1 minus student 2. It should return Alice and Joe, I think, because they're not here. Yeah, let's see. Oh, Jane, Alice, and Joe. Yeah, Jane, because she's here. She's 21, and that's a different Jane. There's another Jane that's 19 years old. Okay. Oh, sorry, no, 19 years old right here. So it's a different Jane. Okay, let's do one join. For example, okay, let's do natural join. In this case, in our case, it will be natural join, but it doesn't have to be. Okay, so it joined the two tables, and I basically eliminated the column so it doesn't repeat. It cannot repeat because it's dictionaries. But if it was named, if it was, for example, our student 2 was named, sorry, if enrollment was named something, or the student names were not named but as name, it will show up as another column here. Okay, I want to show chaining because the rest of the command are easy to see, but let's see. Now, in this case, we'll find students that are 18 years old first, and then we'll print only their names. So let's see. Let's see which ones are those first. 18 years old is John and Alice, and should just print their names. Okay, boom, John and Alice. And that's it. That's pretty much it. The rest of the operations you can try on your own. I will supply this file in my GitHub account as well. Have a great day.